In this video we are going to explain the trapezoidal rule. So, one of the previous videos talked about a trapezium, which is this shape where the top and the sides are different lengths. That is a bad drawing of a trapezium. So, this is your trapezoidal rule, and it's based on your trapezium. This is your formula for the area formula of a trapezium. So this is used for calculating the area under a curve. The black line is a curve, and then we have split this curve into trapeziums, and we've made this be one, like the top for example, and this is your bottom for example, and then you have a trapezium shape there. So the main part of this is that h is the length between your sections. That has to be the same. So the area of this first trapezium is going to be, this is like y1, it's like your height, y2 your other height. So the area of section 1 is y1 plus y2 over 2 multiplied by h, and that is because it comes from your trapezium formula. Similarly, it's saying here the area of the second section is y2 plus y3, which is there, over 2 and multiplied by h. So therefore the total area, okay, well that makes sense. Then with some algebra, they've done the total area there. So they have 4 sections and they have done out the formula. So what they've done then is they've factored out h over 2 from everything. So that's out there. And then they've added up what's left. So y1, y2, another y2, y3, another y3, y4, another y4. So basically everything except the first one and the last one appears twice. There is 2 y4s, 2 y3s. I think you get the idea. So that gives us this formula here. And you can see here y1 appears once, y5 appears once, and all of these appear twice. So then this is our formula. There's 2 of everything except for the first one and the last one. So the formula is given to you in your log tables. Happy days. It is this here, h over 2 multiplied by this. And in other words, this says here the interval, which is h over 2, the first height, the last height, and add 2 times the remaining heights. I used to learn that because I found it was a wee bit difficult to input your points, but you're given it in this format here in the log tables. Then we have a note. Because the top of each trapezium does not match the boundary at all points, the area obtained by this formula is only approximate. That's important. And we'll just zoom in up here a little bit. If we zoom in here, we see that there's a little section there that's not added. But then there's an extra bit here that's added above this, above the line. That's extra. This is extra. And the reason it's approximate is because those 2 bits circled at the moment are extra, and that is supposed to make up for this little bit that isn't included, and this bit that isn't included. They're supposed to balance out, approximately balance out. So go back to that, it's approximate. Accuracy depends on the gap width of h. So if we got a smaller h value, the smaller the gap, the greater the accuracy, which makes sense. And then note 2, if offsets are measured from the same point above and below the line, then your area of A plus B can be given from this. If they are from the same points above and below the line, the area is approximately equal to this. So that brings us then to our first example. So using the measurement provided, find the area of this shape. And it's telling me that the distance between points is 1. So h is equal to 1. And it gives us our formula. That's how it would be given in your log tables. So here, this is y1. That point there is y1. y1 is actually equal to 0. And then y2 is like this height. Which is approximately 3. So we're going to say y2 is 3. Then y4 is 3.62. y3 was that, so y4 is 2.86. y5 is 3. y6 is 3.58. And y7 is 2.66. And we know h is equal to 1. So then if we fill into your formula first, I would write out the formula. Area is approximately equal to 1 over 2. Or I could actually write h over 2 this time. y1 and our last y number is y7. So y1 plus y7, and then add 2, y2, y3, y4, y5, and y6. Close bracket. I'll do this and then this. Now fill into your formula. That's approximately equal to a half. y1 was 0. y2 is 2.66. And then 2 multiplied by all of these added together. 3 plus 3.62 plus 2.86 plus 3 plus 3.58 plus 2.66. And we can put this into the calculator, and it gives us 17.39 units squared. We don't know what the unit is, so we'll just write units squared. So that's that example done. So that's the approximate area of that shape. So our next example is example 2. So this circle, x squared plus y squared is equal to 25. And it's shown there in your diagram. And we have to find y in terms of x. X squared plus y squared is equal to 25. So find y first. Y squared is 25 minus x squared. So that's y is equal to the square root of 25 minus x squared, which is the square root of 5 minus x. Sorry, the square root cancels out with that square, so we are just left with you could be left with 5 squared minus x squared. We'll leave it like that for the time being, actually. And now if we go on and look at part 2, hence complete this table. So when x is 0, we'll just sub these into your using your calculator. So we get 25 minus 0 to be squared, which is just 5. And you should show that work down here. With this down here, we can't actually get the square and the x to cancel, because we would need the whole thing to be squared for a square root to cancel with the square. We'd need the whole thing to be squared, and then we'd be left with whatever's in the bracket. But here, unless if you wanted to write this as 5 squared minus x squared, to write that as 2 brackets, it would be 5 plus x, 5 minus x to be squared, not, which is the same thing as this, not that is something different. If you multiplied that out, you get 25 minus 10x plus x squared, and we don't have a 10x up here, so we can't do that. So that's finding y in terms of x, and I have that written up here. Now, using that, complete this table. So when x is 0, find y. Well, that's just going to be the square root of 25, which is 5. Then we'll show some work for the rest of these. Part 2, y is equal to 25 minus x squared. So when x is 1, y is equal to 25 minus 1 squared is just 1. So we get the square root of 24. And the square root of 24 is going to be a long decimal place, so I'll just write that up here. Square root of 24. Then when x is equal to 2, we have y is equal to 25 minus 2 squared, which is 4. So that is 25 minus 4, which is the square root of 21. And so on with the rest of these. You could show your workings and sub in 3. Well, we'll do that one as well. You have your formula, y is equal square root of 25 minus 3 to be squared, which is 9. So 25 minus 9 is 16. We get the square root of 16, which is 4. So that works out to be 4. And the rest of these, the next one is 3. And when you sub in 5, you get 0. You could have seen that one from your graph down here. Use the table to estimate the area of the quarter circle using intervals of h is equal to 1 unit. So that's going to be your trapezoidal rule. Now we know our heights. So this is like the equivalent of y1, y2, y3, y4, y5, and the this is height 6, y6. So it's also important to note here there are 5 strips. So that means there's going to be 6 heights. So that's an important note. If there was 10 strips or 10 sections, there is going to be 11 heights. Or n strips, you're going to have n plus 1 heights. Also a little side note there. So we're going to use your trapezoidal rule when h is equal to 1. So part 3. Trapezoidal rule, and it is good practice to write out your equation, taking it down from the log tables. So area is equal to h over 2 y1 plus yn, and then we're going to have 2 multiplied by y3, y4, all the way up to yn minus 1, close brackets. So here that tells us that our area is approximately equal, h is 1, so 1 over 2, and then y1 was 5, so 5, and y6 was 0. So that's your first and your last, 2 multiplied by all of the values in between. So root 24 plus root 21 plus 4 plus 3, close brackets. And when we put that into the calculator, we find it is 19.404 square, or units square, or you could say square units. And that's the answer to that part. Actually, I've calculated that wrong. And when you put that into the calculator, you get 18.982 square units. And that's the answer to that part. So we'll look at part 4. Complete the table below using intervals for h is equal to 0.5 units. So using the same method as before, sub in, you could use your table function in your calculator. The step this time is 0.5. So you could actually do that with your calculator in table mode. Start is 0, stop or end is 5, step is 0.5, and that is the function that you'd put in. Y is equal to 25 minus x squared. When you do that in table mode, and it would be very good practice to do that just to get used to using table mode, you get 5, 4.975, 4.899, 4.77, we get 4.583, 4.33, 4, 3.571, 3, and 2.179. So doing our trapezoidal rule again, part 4, again write out your rule from your log tables. There's your rule. This one is going to be a little bit longer because we have more points to add. So we have area is equal to 0.5 over 2. Y1 is 5. And our last point is 0. And now we have 2 by 4.975 plus 4.899 plus 4.77 plus 4.583 plus 4.33 plus 4 plus 3.571 plus 3 plus 2.179, close brackets, and we can put that into your calculator all at once, and that gives us 19.404 units squared. Just go back to the question. So now compare both answers with the answer obtained from the area of a disc formula corrected 3 decimal places. So we look at area of a circle formula. Area of a circle is equal to pi r squared. So here we're getting area of a quarter circle is a quarter pi r squared. And in our case, we'll just check what the radius is. The radius is equal to 5. So we get a quarter pi by 5 squared. And when we put that into the calculator, we get 19.635 square units. And comparing that to the other two, we had 18.98 up here, 19.404. So the final little bit we would have to add there is what I talked about in an earlier part of the video. As h gets smaller, h is your interval. So as h, your interval length, as that gets smaller, the area gets closer to the actual value. We could also note both approximations are smaller than the true value. As would be expected, from your graph. And that's the end of that example. Thanks for watching, and I hope that helps.